Hello all, I am Ashwati S. from Food Technology Department. Today we are going to talk about physics in food processing. The topics we are going to discuss today are thermodynamics in ice cream making, cooling of ice cream before freezing, physics in whipped cream. Thermodynamics in ice cream. The ice cream is made of milk, cream, sugar, water, and pinch of agar and gelatin. Blended together, these ingredients form a syrupy liquid. This liquid mix is transformed into solid dessert by removing heat energy, that is, by freezing it. And this illustrates an important science concept. The form or phase of matter can be changed by adding or taking away energy. But heat energy does not simply vanish. First law of thermodynamics. Scientists know this principle as the first law of thermodynamics. In a home ice cream maker, the heat energy is taken up by a mixture of ice and rock salt. Because nature tends to work to even things out. Scientists call this principle the second law of thermodynamics. Heat energy is transferred from the ice cream mix, which has more heat energy, to the mixture of ice and rock salt, which has less heat energy. First law of thermodynamics says that energy cannot be created or destroyed. It can only be changed or transferred from one object to another. The first law states that the heat supplied by the environment, the blender, to a system, ingredients to make ice cream, is equal to the change of internal energy inside the liquid, ice cream in this case. Second law of thermodynamics. The second law is that in a natural process, heat is always transferred from a body with a higher temperature to one with a lower temperature and never the other way around. If we wanted to do the opposite, it would be through an artificial process with the intervention of a work. This brings as a result, according to the second law, that the efficiency of any device or machine can never reach 100% because it would be a perfect and perpetual machine, something that has never been observed. Have you ever tried to restore a dish of melted ice cream by putting it into the freezer? If you have, you know that the resulting frozen substance is hard and unappetizing, more like ice than ice cream. Why? One of the most important ingredients of ice cream is air. Turning the crank on a home ice cream maker stirs air into the mix, as well as helps the mix cool evenly. Tiny bubbles of air, about zero point 0.1 mm across, make ice cream soft. Ice cream plants use a similar process, but on a larger scale. For example, large fan like blades replace the hand crank. Spinning at a high speed, the blades whip an enormous amount of air bubbles into the frozen mix, causing its volume, amount of space an object takes up, to increase. The increase in volume is what makes ice cream soft. If air bubbles were not added to your favorite flavor of ice cream, eating a spoonful of it would be like eating a sweetened ice cube. Cooling of ice cream. This also has to do with making a better texture ice cream. For a creamy, smooth ice cream, you want to have lots of small, evenly dispersed ice crystals. If the base is room temperature before you put it in your ice cream machine, it takes a long time for the ice cream to freeze and you get large ice crystals. But if you refrigerate the ice cream base so that it's cold from the get go, it will freeze quickly and you will get small ice crystals. Even though you may want to skip this step and get to ice cream as soon as possible, it's worth it to chill your ice cream base before you make it. This is yet another reason why liquid nitrogen ice cream tastes so great. Here you can see a small video of how liquid nitrogen ice cream is made. Why do so many recipes call for salt on the ice? If you are making your ice cream with a crank machine or a bag, almost every recipe calls for ice and rock salt. It's for the same reason cold parts of the country spread salt on wet roads when it's close to freezing. Adding salt lowers the freezing temperature of water, and for wintry roads, it means that the water won't freeze as easily. For our ice cream, it allows the temperature of the mixture around the ice cream to get colder. Since the ice cream isn't just water, its need to be a little below 32 degree Fahrenheit to freeze. When you're using a crank ice cream machine, you frequently have to add more salt and ice. so you can watch the process of melting ice more than once. The physics of whipped cream. There are two physical principles involved in making the delicious white fluffs, the canned ones. First is the liquid gas. When the canned whipped creams are made, half the bottle is filled with cream, although these days it's usually hydrogenated vegetable oil, and the other half of the bottle is filled with liquid gas. To liquefy gas at high temperature, great pressure is applied to the gas, and consequently, the pressure inside the can is much higher than the pressure outside of the can. The liquefied gas mixes with the cream inside the bottle, and when we tweak the valve, which works to equalize the pressure inside and outside the can, the pressure inside the can decreases and some of the gas evaporates, making a gas layer on top of the can. This layer takes up a large volume and pushes the liquefied gas plus ice cream through the tube out of the can. When the liquefied gas inside cream comes out of the can and experiences sudden increase in pressure, they also evaporate, making air bubbles. These air bubbles are trapped inside the cream, making the cream fluffy. Second phenomenon is the shear thinning. The whipped cream, when it's coming out of the can, flows out like liquid, but once it sits on top of the whatever drink you have, it stays put like solid. This is because when the molecules of the cream slide or shear past each other, the viscosity of the liquid decreases temporarily and the cream flows. Here you can see how a whipped cream comes out of a whipped cream dispenser. Here we come to the conclusion of our video. Physics is a science that is part of everyday life, even when it comes to how we cook. Nowadays, modern physics is making work easier in different areas of our lives. Hope you have learned something from this video. Thank you.